My name is Xin. I'm a researcher from the Cognizant AI Lab. Today, I will briefly introduce our latest work on using evolution strategies to fine-tune the full parameter of large language models. So as you may already know, almost every single large language model currently we are using has been fine-tuned to either incentivize their reasoning capabilities or to make them better aligned with human preference. Traditionally, this fine-tuning step is done using a technique called reinforcement learning, which I will refer to as RL. However, RL actually has several limitations when it's applied to large language models fine-tunings. First limitation is that RL usually needs a stepwise reward, which means that it will be better if we can have token-level reward. However, this turns out to be very difficult to do, and also it may not be helpful compared with outcome-based reward. So this makes RL not a very natural fit for this problem that with very long horizon and sparse reward. And the second issue is that RL is also sensitive to hyperparameter setup, and it may even show high variance across different rounds with the same hyperparameter setup. So this makes its use very expensive. And the third issue is that RL is also easy to hack the reward, so it may lead to undesirable behaviors of the fine-tuned large language models. And the last issue is that recent literatures show that RL is also sensitive to the selection of base models, which means that for different base large language models, the same RL technique may show very different performance in fine-tuning them. Some may work, some may not work, so it makes RL less reliable for the fine-tuning tasks. However, we do not have any better alternatives currently compared with reinforcement learning for these fine-tuning tasks. And in this work, we try to propose a new alternative to reinforcement learning for fine-tuning larger models that can overcome all the limitations I just mentioned. So evolution strategies, which I will refer to as ES, it is a population-based zeroth order optimization algorithm that has been used for the last 20 to 30 years in those traditional optimization problems. And because it's zeroth order, so it does not need to calculate any gradient or do backpropagation. And it also shows a comparable performance to RL in those traditional control and gaming problems. However, it received much less attention, and it is almost ignored in the era of large language model because people do not believe that ES can be scaled up to optimize billions of parameters simultaneously. And in this work, we prove that it is not only true that ES can be scaled to optimize billions of parameters, but also it shows a better fine-tuning performance than the latest RL techniques in several aspects. So we compare the performance of ES and RL in a countdown task, which is a symbolic reasoning task that is commonly used by benchmarking the other RL fine-tuning methods. And this problem has a long horizon and sparse reward, so it is difficult, and also it can showcase the power of fine-tuning techniques. And during our experiments, the evolution strategies shows consistently and significantly better performance than RL in all the tested cases with different large language models. And also, we run experiments to further compare ES with RL in a task. We are trying to fine-tune the larger model to be more concise. And in that experiment, we observe that ES shows completely different behaviors than RL and has several good advantages compared to RL. So based on our experiments, we observed that ES actually has even a better sample efficiency compared to RL in the fine-tuning tasks, and it has a good tolerance to the long horizon rewards, and it's also robust to the choice of base language models and hyperparameters, and it shows a less tendency to hacking the reward, and it also shows a much more stable performance across different rounds. So all these advantages makes ES a very promising alternative to RL for the future fine-tuning tasks, and it also opens up new opportunities in this space. So check out our paper and open source code for more details. Thank you.